Good morning, students. So I hope all of you understood the last two examples. Especially here we have to know the Thales theorem and the converse of Thales theorem. So I hope all of you understood the statement of Thales theorem as well as the converse of Thales theorem. So with related to this Thales theorem, actually we have done two examples. Example number 1 and example number 2. So I hope all of you understood these two. So now today with related to the converse of Thales theorem, so here we have to do one example, and which one is example number 3. And if you see the example is here like in this way given in figure. So if you see the figure is also mentioned here, PS by SQ equals to PT by TR and angle PST equal to angle PRQ. This one is given to us according to the figure, and now here we need to prove that triangle PQR is an isosceles triangle. So that means here we need to prove the triangle PQR is an isosceles triangle. So first of all, what is isosceles triangle? So isosceles triangle means what? Where two sides are equal. So that means here the triangle PQR we need to prove an isosceles triangle. That means we need to prove here two sides are equal. So first of all, if you see the diagram here, the diagram is given like in this way, isn't it? So diagram is this one. Here the diagram is given P, Q, R. This one is the triangle given, and in this triangle, 2 points are given here like in this way. This point is here S as well as this one is T, as T. First of all, a triangle PQR given to us, and in this triangle inside PQ one point is here S as well as in another side PR, here another point is here T. Is it clear? And now here one more condition is given. This angle P as T is equal to what? This angle. That means PRQ. This angle is equal here. These two angles are equal given. So first of all here what you have to do, if you see the diagram here, in this diagram if you ignore these 2 points S and T, so ultimately here PQR is a triangle, and this triangle here we need to prove two sides are equal because we need to prove isosceles, is not it? So any two sides here, it may be PQQR or it may be PQPR, we don't know. So we need to prove here. According to these two conditions, we need to prove. So especially in this question here, some results are given, like the ratios are given here. Which one? PS by SQ equals to PT by TR given to us. At first, when we have to solve this one, solution here, at first you have to write given that. So whatever given here, we have to write given that. The first condition is given here, PS by given that. This one we have to write PS by SQ equals to, this one we have to write here PT by TR. This one is given to us. PS by SQ and PT by TR. This one is given. So now here, if we recall the converse of Thales theorem, what is the meaning of converse of Thales theorem? If the ratios are equal, that means PS by SQ is equal with PT by TR. If the ratios are equal, then their sides, that means whatever we write ST, this ST is always parallel to QR. According to our Thales theorem, we know if the ratios are equal, then the sides are parallel, these two are parallel. And according to our Thales theorem, what? If these two are parallel, ST is parallel to QR, then the ratios are equal. That means PS by SQ, PT by TR we get. But here we need the converse one because this result is already given to us. For that reason here, PS by SQ is equal to PT by TR given. So that's why from the converse of the Thales theorem, what we can write here, this ST is parallel to QR, easily we can write. Is it clear? So that's why here you have to write. So by the converse So by the converse of Thales theorem, or simply you can write converse by converse of the Thales theorem. In this also you can write whatever you want. So by the converse of Thales theorem, what we can write here? Ratios are equal, so that's why easily we can write here ST is parallel to QR. Is it clear? This one we write ST parallel to QR. This one is the converse of Thales theorem. I think all of you understood this one. Okay, now after it you see here. One thing you see here, in class 9 we discussed this type of conditions. If two lines are parallel, for example, so this one is two line here, this one is suppose line L, this one is line M, for example, if we consider. And now if we draw a line like in this, what is the name of this line? So all of you know this one is known as transversal. Is not it? So if this line parallel to second line, if these two lines are parallel, remember this one? So L and M are if parallel, then this intersecting line, this line is known as transversal. If it is transversal, then what we can say about these two angles? These two angles are known as corresponding angles. In class 9 we discussed this one, isn't it? So these two angles are known as corresponding angles. So the same thing, if you see here, already we proved ST is parallel to QR because by the converse of Thales theorem. So if these two lines are parallel, so this SQ is also known as transversal here, isn't it? If you increase the line, look like this transversal. So simply here, if ST is parallel to QR, then obviously this angle and this angle, you see these two angles are known as here corresponding angles by this logic, isn't it? So from here what we can say, these two angles are corresponding angles. So therefore here easily you can write here, therefore angle, which angle? PST. This one we write here, angle PST is equal with angle, this one we write what? PQR. So this one we write here PQR. In bracket what you have to write here? Corresponding angles. Corresponding angles. Is it clear? And we put this one is equation number 1. Angle PST equal to PQR. All of you understood this one? Since this ST is parallel to QR, for that reason these two are corresponding angles according to this. So now here again also given, the next you see here also given one more condition given to us. Which one is given? Angle PST. That means this angle PST is also equal to which angle? Angle PRQ. This one we write here angle PRQ. Is not it? Already given to us this one. So PRQ. So this one we put equation number 2. I repeat this one more time. This one is given PST is equal to PRQ. So PST equal to PRQ given. So if you see, if you compare these two, equation number 1 and equation number 2, PST equal to PQR as well as PST equal to PRQ. So from here we can write from 1 and 2. From 1 and 2, if the left hand sides are equal, that means the right hand sides are also equal. So that's why here we have to write angle, this one is PQR is equal with angle PRQ. All of you understood this one? If the left hand sides are equal, then right hand sides are also equal. Now here you see one more condition we know. In case of in a triangle, if you see, if you consider a triangle ABC, for example, here another condition you see, if angle B is equal with angle C, for example, for this angle B, the opposite side is which one? AC. And for this angle C, which one is the opposite side? This one is the opposite side. If the angles are equal, then their opposite sides are also equal. We know, isn't it? So that means from here we can say if angle B is angle C, then for B the opposite side is AC is equal with AB. The opposite sides are equal. So the same condition if we apply here PQR and PRQ. Which one is PQR? PQR, that means this angle. and which one is PRQ? PRQ, that means this angle. So if PQR is equal to PRQ, that means for this PQR, the opposite side is which one? PR. So in place of this one, we can write this gives us PR, is not it? And for this PRQ, which one is the opposite side? Opposite side is PQ. So that's why here we have to write this one is PQ. So PR equal to PQ we get. If the angles are equal, then their opposite sides are also equal. For that reason, here we write PR equal to PQ. So how many sides are we get here equal? In this triangle PQR, how many sides are we get equal? Two sides. One is PQ, another one is PR. You see here, PR equal to PQ we get. So from here, what we can say? Hence, this triangle is an isosceles triangle. Why? Because two sides are already we proved here. Is it clear? So I hope all of you understood this one. So in our next class, we start our exercise 6.2. Is it clear? Okay, thank you.